This is a video on working with polynomials, and this will be our first example where we were given a polynomial function and we need to provide the end behavior, the intercepts, the multiplicity of zeros, the sign table, and graph it while we are explaining our work. So first, to find the end behavior, I'm going to look at the leading term. The leading term is 1x to the fourth. Because the leading coefficient is 1 and it's positive, and the degree is 4, which is even, this function will rise to the left and will rise to the right. To find the y-intercept, we will just plug in x equal to 0 and find f of 0. F of 0 will be 0 to the fourth and 0 to the third and 0 squared and 0 minus 16, so it is negative 16. The y-intercept is the point 0 with negative 16. Let's start to put all these on a graph. So let's say that this is 0 with negative 16. That's going to be my y-intercept. The x-intercepts, I will first start with rational zeros, which are easier to evaluate and to guess. The rational zero theorem says that if I find fractions that have factors of the constant term, which is negative 16, over factors of the leading coefficient, which is 1, these are possible rational zeros. These are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. I'm supposed to check each one of those. Negative 4 is a zero of a function, and I'm going to perform synthetic division. So I'm going to write negative 4, and then I'm going to write the coefficients of f of x: 1, 10, 31, 24, negative 16. Drop the 1, multiply by negative 4, add 10 with negative 4, multiply by negative 4, add 31 with negative 24, that's a 7, multiply with negative 4, add, that's a negative 4, multiply, that's a positive 16, remainder equals to 0. Great, this indicates that negative 4 is indeed a 0. Negative 4 is a 0 again, so I'm going to perform a second synthetic division. So I'm going to drop the 1, I'm going to multiply by negative 4, add, that's a 2, multiply by negative 4, add, that's a negative 1, multiply by negative 4, and add, that's another 0. And now I know that negative 4 is a second 0 again. The quotient of this division is 1x squared plus 2x minus 1, and I can find the zeros of that quadratic using the quadratic formula. Negative b is negative 2 plus or minus square root of b squared minus 4ac divided by 2a is equal to negative 2 plus or minus the square root of 8 divided by 2, which simplifies to negative 2 plus or minus 2 square root of 2 divided by 2, which simplifies to negative 1 plus or minus the square root of 2. So these are the other zeros. So negative 4 is a 0 that has multiplicity 2. And negative 1 plus or minus square root of 2, they have multiplicity equal to 1. And I will now put them on the graph so that I can see them. This is negative 4 here, This is going to be negative 1 minus the square root of 2. This is going to be negative 1 plus the square root of 2. I'm going to do the sine table, so I'm going to draw the real number line from negative infinity to infinity. A row for x plus 4 squared, which is going to be one of the factors of the factorization of f of x. A row for x minus negative 1 minus negative 2. And a row for x minus negative 1 minus square root of 2. X plus 4 is 0 at negative 4, and it is positive in all other intervals. X plus 1 plus the square root of 2 is 0 at negative 1 minus the square root of 2, and positive when x is greater than and negative when x is less than, to the left, the 0. And x plus 1 minus square root of 2 is 0 at negative 1 plus the square root of 2. It is positive when x is greater than, and that's to the right, and negative when x is less than, which is to the left of its 0. F of x is the product of these factors. So from negative infinity to negative 4, it's going to be positive. It's going to be 0 at x equal to negative 4. Positive between negative 4 and negative 1 minus square root of 2. 0 at x equal to negative 1 minus square root of 2. Negative in the next interval, 0 at the next 0, and positive in the next interval. When graphing, positive indicates positive y's, and positive y's are above the x-axis. So I will be graphing in the positive part of the plane. Negative f of x indicates negative y's, and that will be the bottom part of the plane below the x-axis, and 0 indicates 0 y's, and these will be the intercepts. So negative 4, negative 1 minus square root of 2, negative 1 plus square root of 2. So I'm going to start on the left, and I'm going to graph positive, which means above the x-axis, and then when I hit negative 4, I have to stay positive, so I'm going to have to bounce up and come back down to negative 1 minus the square root of 2. I need to cross this, become negative, go through my y-intercept, come back up to the 0, and then cross to become negative and draw arrows. As you can see, the sine table also verified the end behavior. I ended up with going up on both the left and the right. My graph is ready and my work is shown.